Greetings, my name is Eric Bang, and I will be starting off the presentation for our ICS 161 prototype. Here is the information as requested from the documentation of this assignment. We will be dividing this video into three parts, with each of our members taking a specific section within the presentation as to make sure that everyone has a part. This was done as a result of people being unable to all meet at the same time to perform one recording session, and so it will be separated for the time being and merged together at the end. So here's the prototype, the what and the why. Our objective is to create a thermodynamic simulator. Essentially, players will control a metal ball which can retain temperature. For example, stands in fire, the metal ball gets hot. Stays in cold area, the ball will get cold, and interactions with the environment to transfer temperature to other objects. So, for example, if the metal ball, which is very hot, suddenly touches something like ice, it will start melting the ice. Or perhaps you will be able to physically see with a different lens that the temperature is currently increasing in a certain area and decreasing in another, with effects based on the object. Like, for example, the aforementioned ice, or maybe if you were to touch a log, it will start catching on fire if you're too hot past a certain temperature. But why? We thought, well, some of our group members thought that it would be a very interesting topic. For example, one of our group members initially thought of this idea as a result of their physics demo, and they found that it would be a very interesting way to deal with the entire thing. Now, as for me personally, I thought that it would also provide a very good balance between physics, animation, and rendering, which are the three core aspects, the three pillars of our project requirements. For physics, we have heat and movement. Not only do we have to move certain objects, but we also have to deal with thermodynamics, which is, in a way, physics. Well, at least the field, the part of physics, at least. Then there's animation. We do need to create some animations, or at least perform some minor things for, such as the ice being melted, maybe animating the ball that the player will control so that it moves a little bit more reasonably, etc. Then there's rendering. We do have to create the materials for the objects that we're trying to create. When the ball heats up, we plan for it to glow. So the rendering will have to take care of some of the shaders for that particular material. And of course, we will also need to code and the triggers and everything for making certain things occur, but that can be arranged later. But in short, it provides a good balance between physics, animation, and rendering, and our group members really do deem that it is a very interesting thing with some depth to it as well. It's not as simple as just I will create this ball and suddenly it increases in temperature and we're done. There's interactions between objects in the environment. There will be player controlled areas. We will allow players to be able to manipulate the environment to an extent. We remember it's not a full project, so it won't be as great as, say, a 10-week course project, but we do plan to give it our best shot here. As for the engine choice, we plan to prototype this in Unity for a number of reasons, the most important being all members of the group have experience with the engine. As a result, we are a lot more flexible with it than we would be if we tried Unreal, for example. Granted, not and that's not to say that nobody in the group has like experience with Unreal. It's more that we are more experienced with Unity. We are more, as a result, we are also more. It's very good for us because we will be able to prototype significantly faster had we had to learn a new engine and work through Unreal's documentation as well. Additionally, Unity is very flexible. With the knowledge that we have, Unity is extremely flexible when working with our demo concept. For starters, because of the way Unity deals with components, it will be extremely easy to modify and actually build the prototype with some of the more built-in features of Unity, such as triggers. We will be able to easily deal with collision detection and, well, fix some of our issue, or fix and get to a reasonable point where we can actually have something ready to show. Because one of our targets of opportunity for this project is that we want to be able to tell whether or not the metal ball the players control is colliding with another object. And we want to make sure that the collision at a certain temperature will cause certain things to trigger in the script. Also, Unity has very good ease of importing assets, which reduces the need to export it to other programs. For example, we will not have to export from, say, for example, Maya to some other file size and then into Blender, or excuse me, into Unity. We could go straight into Unity. most of the time. Sometimes there will be other issues as well. And of course, there's also reasonable methods for setting up collaboration. We can use Git repos for ease of use with minimal setup, since all we need to do is just simply have a section where certain items will be placed in, make sure we have the actual git no refile, and suddenly all of us are able to push and pull from a repository. Or alternatively, we can also use Google Drive. Slightly a little bit more annoying since we would have to zip the file constantly, but it is also a reasonable way for us to work with. And overall, Unity just tends to be, for us at least, was the more efficient option. Just simply as a recap, we have more experience with it. In terms of our concept, we believe that it will be significantly more reasonable and flexible, especially since we are working with a lot of collision detection, a lot of numerical formulas in order to actually get the heat transfer, get the thermodynamic simulator to be somewhat accurate to what we want it to be. And there are reasonable methods for setting up collaborative efforts that we believe we can actually execute.
Hello, my name is Patrick Goodekunst, a group member in Prototype Group 53 for GDIM 33. And I will be continuing this presentation by talking about the group details of our prototype project. The development schedule for our prototype will be made up of individual phases. Phase 1, which we are currently in, is discussion. We are discussing which features to include, and we're creating a list of required assets. We will continue to mock concepts up and figure out what we want to include in the game. Phase 2 will be testing. This is when we will be opening up Unity and making game objects. We'll be giving them their most basic and necessary game components, like when we will make an object controllable by player input. This object will be the middle ball that was mentioned in previous slides. We'll be writing scripts that also keep track of individual game objects' temperatures. Getting the programming right here will be especially important, as the gameplay loops will revolve around different objects having different temperatures. We will also be adding in game objects that either increase or decrease the temperature of the player character, likely using box 3D colliders that are available in Unity. Phase 3 is when we'll start fine-tuning. We'll start adding in artistic assets that make the interactable game objects look like real-world objects, i.e., what used to be simple free-floating fire in some of our game objects will become matches and stovetops. We'll also be adding in special effects, and we'll be working on the physical properties and equations. This will require doing more research and testing to make sure that the objects are heating up or cooling off at a noticeable and predictable rate, similar to a real-world object that is made of the same materials and has the same temperature. Phase 4 will be when we make a playable prototype. We will have the players be able to do something interesting with the established physics properties of the objects. I.e., make a simple puzzle that uses heat transference and heat loss. In this phase, we should already have all the tools and foundation available. Now we will come up with something fun for the players to do.
Hi, my name is Austin Delpena. I'm the fellow member for Group 53. I'll be going over group detail and concluding the presentation. We all agree that everyone will be taking a generous approach to group division. This is because we can confidently say that we have enough experience in other fields, such as animation, to specialize for this project. As such, we will be helping each other design certain aspects of the project. This includes the aforementioned animation, coding, map design, interactable object design, and all that and all such. To summarize our project, we are creating a game demo centered around thermodynamics. The player will interact with the world and use temperature to solve puzzles. We are using Unity for this demo as it is the engine we all have the most experience with. Means we'll mostly take an online format and will be relying on Git for version control. Currently, we are using Discord to communicate with one another. Finally, everyone will have a general role in the project. This concludes the presentation.